Okay, so we're solving differential equations again, but we're going to go a step further now because those plus c's that we've got on the end of our answers don't have to stay that way. More about that in a minute. For starters, we can attack this the same way we've been doing in the previous units. They give us a differential equation, dy. I'm just going to multiply both sides by dx to make it look like this. So they've differentiated something and came up with this, so the original must have been dy would have come from y. The 4x would have come from power goes up by 1, then 4 divided by 2 gives 2, so there's our original, and plus c. So there's our original function before the derivative was taken, and it's got this thing in it, which so far we've just been leaving those plus c's and calling it good. But just as quadratic equations wouldn't be all that interesting if we never knew the values of a, b, and c, integrals and differential equations wouldn't be much use out in the world if we never knew the values of these c's. So there's got to be a way to find these, and typically there is. And it's what we call initial conditions or boundary conditions, something like that. We need to know some point on this function, and if we know even a single point, usually that is enough for us to nail down the value of the c. In this case, they're telling us y comes out to 7 when x is 1. In other words, this function goes through the point 1, 7. You can see how that can help us out. If x is 1, y is 7, we can take this function and say, okay, y, you're 7. X, you're 1. C, you're now cornered. You're the only variable left in this thing, so we should be able to solve for the value of c now. 7 equals 1 squared is 1 times 2 is 2, plus c, subtract 2 from each side. C must be 5. So good. C is demystified now, and our function no longer has a c in it, or it no longer has an unknown c. We just found it. So the first few steps of this went just the way they did before, but now when we get the c, we don't have to stop. If you know a boundary condition, you can use it to find the value of that c, and now you have a better answer.